We'll solve the following log equation using the one-to-one property of logs. First, on the left-hand side, we'll use the property of logs that says when you have the sum of two logs, so the sum of log x and the sum of log x minus 1, that it can be rewritten as the log of a product. So now I have a single log on the left-hand side, and that log is of the product x times x minus 1. To be clear, we'll use brackets here. I'm taking the log of a product now. We're going to do the same thing on the right-hand side. So we have the log of the product, not a product. This is a subtract right here. See the subtract symbol? So on the right-hand side, we're actually going to have a quotient. So the numerator is 8x subtract 12, and the denominator is 2. Now, not all log equations happen into this situation, but this one does. It's really a nice little trick. So let me write the one-to-one property of logs. It says if you have, if you have log base A of m, this is in general, equals log base A of n. So let me draw attention to the fact here that we have log base A and log base A, and those are the same bases, and that's true on our problem. This happens to be base 10 and base 10. Then you can set m equal to n. And it's really similar to the one-to-one property of exponents. It's a really nice property, and it gives you something that's easier to solve. So that's the one-to-one property of logs. Now let's apply it to this problem. We're able to basically, I'm going to take a pink pencil here and mark these off. That's what the one-to-one property does. If you have a log equals a log, now there's nothing added, subtracted, multiplied, or anything on the outside of the log, you can then ignore the logs. So what we have now is x times x minus 1 equals 8x minus 12 over 2. Now this is going to end up being a quadratic equation. So we're going to multiply this on the left-hand side. We get x squared minus x is equal to, and then on the right-hand side we can do the division. That denominator 2 is under both the 8x, which now is 4x, and it's also underneath the 12, so that's minus 6. Now let's put all the like terms together. We'll put that on the left-hand side. X squared minus 5x plus 6 equals 0. This factors nicely. We have the quantity x minus 2 times x minus 3. You can just double check that real quick if you want to multiply it out using FOIL. You would get back to this line right here. Now we're going to use what's called the zero product property. This should be familiar. And it says that if you have two factors, that factor is x minus 2, and another factor, x minus 3, and the product is 0, then one of those factors has to be 0. So if the first one was 0, you'd have 2 for an answer. And if the second one is 0, you'd have 3 for an answer. Now, when we do these problems, you have to check to see if the solutions actually work. Because remember, we're not allowed to take the log of a negative number. So let's look back at the original problem, and would those two numbers work? If I put in an x equals 2 here, I would not be taking the log of a negative, so that'd be okay. If I put it in here, I'd have 2 minus 1, which is log of 1, that's fine. If I put it in here, I'd have 16 minus 12, which is 4. So all those locations will give me a fine positive number. That's just fine. Now I check x equals 3, and it checks. So in all 3 locations, I will have a positive when I go to take the log. So we do not rule out any of these solutions, or either of these solutions, I should say.